Our Earth is a dynamic, ever-changing planet. It might look still, but beneath our feet, there's a whole lot of action happening. Imagine a giant jigsaw puzzle, but instead of cardboard, it's made of massive rock slabs. These slabs are constantly moving, bumping into each other, pulling apart, or grinding past one another. These are Earth's tectonic plates, and their movements are the driving force behind earthquakes, volcanoes, and the very shape of our continents. Tectonic plates are like giant rafts made of solid rock, floating on the semi-fluid layer beneath them. They make up the Earth's lithosphere, which includes the crust and the uppermost part of the mantle, forming a rigid shell around our planet. These plates aren't all the same though, they vary in size, shape, and composition. We have oceanic plates that are thinner and denser, primarily composed of basalt, and continental plates that are thicker and lighter, made mostly of granite. What makes these colossal plates move? It's a fascinating process driven by forces deep within the Earth. Deep within the Earth's mantle, there's a tremendous amount of heat generated by the decay of radioactive elements. This heat creates convection currents, similar to boiling water in a pot, where hot material rises and cooler material sinks. The hot material rises, cools, and sinks, creating a circular motion that drags the tectonic plates along with it, causing them to move. It's a slow process, but over millions of years it dramatically reshapes our world, forming mountains, causing earthquakes, and creating new ocean basins. The boundaries between tectonic plates are where the real action is. These boundaries are dynamic zones where the Earth's crust is constantly being reshaped and reformed. There are three main types of plate boundaries: divergent, convergent, and transform boundaries. Each type of boundary plays a crucial role in the geological processes that shape our planet. At divergent boundaries, plates move apart, creating new crust as magma rises from the mantle. This process is like a conveyor belt, continuously adding new material to the Earth's surface. Think of the Mid-Atlantic Ridge, where the North American and Eurasian plates are pulling away from each other. This underwater mountain range is a prime example of a divergent boundary in action. This process is slowly making the Atlantic Ocean wider. Over millions of years, the ocean basin has expanded, creating more space between the continents. Convergent boundaries are where plates collide head-on. These collisions can create some of the most dramatic geological features on Earth. If an oceanic plate meets a continental plate, the denser oceanic plate dives beneath the continental plate. This process is known as subduction and is a key driver of volcanic activity. This process, called subduction, creates deep ocean trenches and volcanic arcs like the Andes Mountains in South America. These features are a testament to the immense forces at work beneath the Earth's surface, constantly reshaping our world. Section 4. The Earth's Shapers. Tectonic plates are the master architects of our planet's surface. These massive slabs of rock, floating on the semi-fluid asthenosphere, are constantly in motion. Their movements are responsible for the creation of mountains, volcanoes, and earthquakes. The dynamic interactions between these plates shape the very landscape we live on. When plates collide, they can buckle and fold the Earth's crust, pushing up towering mountain ranges like the Himalayas. This process, known as orogeny, is a slow but powerful force. The ongoing collision between the Indian and Eurasian plates is still pushing Mount Everest higher every year. This relentless movement adds a few millimeters to its height annually. Volcanoes often form where plates converge, and magma rises to the surface. These fiery mountains are a direct result of the intense pressure and heat generated by tectonic activity. The Ring of Fire, a zone of intense volcanic and earthquake activity around the Pacific Ocean, is a testament to the power of plate tectonics. This region is home to 75% of the world's active and dormant volcanoes. Earthquakes happen when plates get stuck and then suddenly slip past each other, releasing tremendous energy. This sudden release can cause devastating effects, shaking the ground and toppling buildings. Understanding these natural processes helps us build better, more resilient structures and prepare for the inevitable movements of our planet's surface. Section 5. Fun with tectonic plates. Did you know that the Earth's tectonic plates move at an average rate of a few centimeters per year? That's about the same rate as your fingernails grow. And because of plate tectonics, the continents are constantly on the move. Millions of years ago, the continents were arranged into a supercontinent called Pangaea. Over time, Pangaea broke apart, and the continents drifted to their current positions. Section 6. The ever-changing Earth. The Earth is a dynamic and ever-evolving planet, thanks in large part to the constant movement of its tectonic plates. These plates are the driving force behind the creation of mountains, volcanoes, and earthquakes that shape our world. From the highest peaks to the deepest ocean trenches, the legacy of plate tectonics is all around us. So the next time you feel an earthquake or marvel at the beauty of a mountain range, remember the incredible forces at work beneath our feet. The Earth's tectonic plates are a constant reminder that our planet is a living, breathing entity, full of wonder and surprises. If you enjoyed this video, don't forget to like and subscribe for more fascinating insights about our planet.